Hello everyone, in this video I'm going to explain about the definition of acid and bases. As we all know, the acidity and basicity of a solution is measured following the pH or the potential hydrogen scale. A pH level has a scale of 0 to 14, wherein a neutral solution commonly has a pH level around 7. An acidic solution has a pH level below 7, while basic solution has a pH level above 7. To know what is the pH level of a solution, we measure it based on the color change on litmus paper. To easily remember the change on litmus paper, there are two acronyms that might help you identify the type of solution. The acronym BRA, which means that when the blue litmus paper turns reddish, the solution is an acidic solution. The second acronym is RBB, which means that when red litmus paper turns blue, the solution is a basic solution. There are three definitions of acid and base from different chemists. The first definition of acid and base is coming from Svante Arrhenius. The definition of acid-base from Arrhenius is a substance that produces hydrogen ions when dissolved or diluted in water. For example, when hydrogen chloride is diluted in water, it will yield hydrogen ion and chloride ion. The definition of base from Arrhenius is defined as a substance that can produce hydroxide ion when dissolved or diluted in water. For example, when potassium hydroxide is diluted in water, it will yield potassium ion and hydroxide ion. The second definition of acid and base is coming from Johannes Bronsted and Thomas Lowry. It is also called as Bronsted-Lowry acid and base. The definition of acid from Bronsted-Lowry is a substance that can donate protons, while the base is a substance that can accept protons. For example, when hydrogen chloride is reacted in water, it will yield chloride ion and hydronium ion. In here, hydrogen ion from hydrogen chloride will move to the water molecule, hence forming chloride ion alone and also hydronium ion. The third one and also the last one is from Gilbert Newton Lewis or Gilbert and Lewis. His discovery about acid and base is called as Lewis acid and bases. The definition of acid from Lewis is a substance that can accept electrons, while the base is a substance that donates electrons. For example, in this reaction, calcium oxide reacts with carbon dioxide will yield calcium ion and also carbonate. In here, dioxide from calcium oxide moves to the carbon dioxide, forming a carbonate. Properties of acid and bases. There are some common properties of acid and bases. From taste, acid is sour and base is bitter. Texture of solution, acid, there's no characteristic texture, while base is usually slippery. The reaction with phenolphthalein, acid is colorless, while base is pink. Reaction with litmus paper, as we all know, acid turns blue litmus to red, base turns red litmus to blue. When react with metals, acid react with metals above H or hydrogen in the activity series to displace hydrogen gas. While in base react with certain metals such as aluminum to form hydrogen gas. And there are many other properties that we can see here. Next is the example of strong and weak acid and bases. So first we have the strong acids such as hydrobromic acid, hydrochloric acid, hydroiodic acid, nitric acid, perchloric acid, and sulfuric acid. Strong bases such as barium hydroxide, calcium hydroxide lithium hydroxide, potassium hydroxide, sodium hydroxide, and strontium hydroxide. Weak acids such as acetic acid, carbonic acid, formic acid, hydrocyanic acid, hydrofluoric acid, and phosphoric acid. And at last, weak bases such as ammonia, diethylamine, methylamine, and sodium bicarbonate. The next one is chemical reactions that involve acid and bases. So the first reaction is where an acid reacts with a reactive metal, wherein when a metal reacts with an acid, it will yield salt and hydrogen gas. For example, in magnesium, when reacts with sulfuric acid, it will yield magnesium sulfate and hydrogen gas. But for copper, when it reacts with H2N, there's no reaction happen, because don't forget about the reactivity series in metals. We can see that hydrogen is more reactive compared to copper, hence copper can substitute hydrogen into this. So we'll continue. The next one is the reaction of acid with carbonate. When a carbonate reacts with an acid, it will yield salt water and carbon dioxide. For example, in calcium carbonate, when we react with two molecules of hydrogen chloride, it will yield calcium chloride, water molecule, and also a carbon dioxide gas. Then, in the reaction of acid with bicarbonate, it's the same. When bicarbonate reacts with acid, it will yield salt, water, and carbon dioxide. For example, in natrium bicarbonate or potassium bicarbonate, when reacts with hydrogen chloride, it will yield potassium chloride, a water molecule, and also a carbon dioxide molecule. The fourth one is the reaction of acid with metallic oxide. When a metallic oxide reacts with acid, it will yield salt and water. For example, in zinc oxide, when reacts with sulfuric acid, it will yield zinc sulfate and also a water molecule. Notice that all of these equations are already balanced. Reaction of acid with metallic hydroxide. When a metallic hydroxide reacts with acid, it will also yield salt and water. For example, in zinc hydroxide, if we are going to react it with nitric acid, it will yield zinc nitrate and also water. Neutralization reaction is when an acid reacts with a base, it will form salt and water. For example, in sulfuric acid, if we are going to react it with potassium hydroxide, it will yield potassium sulfate and also a water molecule. Reaction of base with ammonium salt. When an ammonium salt reacts with a base, it will form another salt, water molecule, and also ammonia gas. For example, in this reaction, calcium hydroxide, when reacts with ammonium chloride, which is an ammonium salt, it will react and yield calcium chloride, 2 water molecules, and 2 ammonia gas molecules. And the last one is the reaction of base with a metal salt. In this reaction, the metal salt will react with the base, forming another salt and a metallic hydroxide. For example, in ferrous sulfate, when react with potassium hydroxide, it will yield potassium sulfate and ferrous hydroxide. Calculating pH and POH. pH stands for power of hydrogen, while POH stands for power of hydroxide. The pH of a solution is a measure of the acidity of a solution. This measure of acidity was proposed by Søren Sørensen. In contrast, POH is the measure of basicity. We must know that pH plus POH must equal to 14, because 14 is the maximum in the pH scale. Then pH is also can be found by negative log of the concentration of the hydrogen ion, while pOH is the negative log of hydroxide ion, of the concentration of hydroxide ion. Sample question number 1. A solution of hydrochloric acid has a concentration of 2.7 times 10 raised to negative 4 molar. A. Find the pH level of the solution. B. Find the hydroxide ion concentration. So first for A, find the pH of the solution. We have the concentration 2.7 times 10 raised to negative 4. First, we will make the reaction. So HCl, when we dissolve in water, it will form H plus ion and also chloride ion. If we react it totally, so there's no HCl left. So H plus has the same concentration as HCl, which is 2.7 times 10 raised to negative 4. So with this, we can find by pH is equal to negative log of the concentration of hydrogen ion. Then we insert the number. pH is equal to negative log of 2.7 times 10 raised to negative 4, and we will get the pH of the solution is 3.56. For part B, find the hydroxide ion concentration. To find hydroxide ion concentration, we need the pOH, since we can also find hydroxide ion concentration from 10 raised to negative pOH. So we can find pOH from pH is equals pH plus pOH is equal to 14. By transposing pH, we will get pOH is equals to 14 minus pH. From part A, we know that the pH is 3.56. So we are going to subtract 3.56 from 14, which is 10.44. Then we'll calculate for the hydroxide ion concentration. So we'll get 10 raised to negative 10.44, and we will get 3.63 times 10 raised to negative 11 molar. The next question is quite easy. Which of the following acid doesn't belong to the group? A. HCl or hydrochloric acid, B. HNO3 or nitric acid, C. HClO3 or chloric acid, D. HNO2 or nitrous acid, and E. HBr or hydrobromic acid. I'll give you 5 seconds, or if you need, pause the video here and try finding the answer. Okay, time's up. So the answer is D, HNO2 or nitrous acid. Because option A, B, C, and E are examples of strong acid, while only option D is an example of weak acid, so it doesn't belong to the group. The third question, which of the following bases can react with a strong acid to form a neutral salt? A. NH3 or ammonia gas, B. NaHCO3 or natrium bicarbonate, C. KOH or potassium hydroxide, D. BaOH2 or barium hydroxide, and E. CH3NH2 methylamine. This is a multiple answer. So again, I will wait for 5 seconds, and you can also pause the video if you need time to find the answer. Okay, time's up. So the answer is C and D. Because both C and D are strong bases, hence if both of them are reacted with a strong acid, they will form a neutral salt. Option A, B, and E are weak bases. So even though they can form salt with a strong acid, they will form a slightly acidic salt. So that's all from me. Thank you for watching this video, don't forget to like, share, and comment on this video. And also don't forget to subscribe our channel.